So thank you for having me. I'm going to be talking about experiment management and reproducible research. My name is Tiago Freitas. I'm a data scientist at Neptune.ai. And today I will be talking a little bit about what kind of alternatives there is for experiment management and reproducible research. How can we do track of our experiments on production, and what kind of tools can we use for that effort. And after that I will be giving a brief demonstration of what can you do with these tools. So let's talk about reproducible pipelines and data versioning. This is extremely relevant, especially in the industry. And it's important to be able to reproduce the pipelines of our models, of our data, and keep tracking of everything in between in different kinds of models, of production models, development models. So it's important to have a tool that takes care of this. So there are two main tools. There are other ones, but I think these two are the main ones. DVC and Pachyderm. MLFlow, that I'm going to be talking a little bit later, also does kind of this, but I'm just going to focus on MLFlow as an alternative for experiment management later. So DVC and Pachyderm, they are different tools, I think, for different solutions. So let's start with Pachyderm. Their slogan is reproducible data science that scales. It's an open source, although it has an enterprise version that you have to pay. There's a data versioning tool that is similar to Git, and it's all based on Docker containers and Kubernetes, and that's why they are able to scale the training of the models, and it's extremely well suited for like big data platforms and things when you are trying to create models in production. It's not that great, in my opinion, in development of those models and doing small experiments. So it does automatically scaling of the workloads using the Kubernetes system. It tracks the data pipelines, and it still doesn't have Git integration. And it's not very easy to install, and that's why, since it is extremely focused on big data and big data pipelines, it's not very suited for like internal and development and experiments. Maybe for production it is a lot more. So it's more like a data engineering tool which has machine learning in mind. And for internal development, I actually prefer a lot more DVC. So DVC is an open source version control system for machine learning projects. It's open source, so it's completely free. It allows you to be able to integrate this in any kind of system that you have. If you want to use a Docker, if you want to do outside of a Docker, if you want to do in whatever environment that you want to use. It allows you to version the machine learning models, that dataset pipelines, and it's extremely efficient in handling large files. So this is a tool that basically allows you to version models, version pipelines. So basically the dependencies of the pipelines. Let's say that you have a pipeline that goes and pick up a data set, pre-processes this data set, and then does some feature extraction, then does a train of a model. The DVC can keep track of everything that's in this pipeline, what are its dependencies, and it can detect if everything in between, if something's changed, it warns you and can retrain if you want. So basically, it's extremely versatile. It's because it's environment agnostic. It's Git integrated, so it's well connected to Git. So the problem with using Git for handling large files is that if you keep track of gigabytes of files, it gets problematic, and DVC handles this by creating a cache version, a cache repository that you can have, for example, on a Google Cloud server or in a local server or on Azure, AWS, or something of your choice. And basically it allows you to keep track of the cache of all this pipelines data and models. And basically the only thing that is Git integrated is it's a cache file that allows DVC to know where to get the information from this data that you are keeping track. So basically Git is not storing on the repository your large files. DVC is on a remote server or in a local server. So as long as you have access, or multiple teams have access to the same repository, whether it is local or remote, all you need to do is you can pull the data and the pipelines in a very slow time. So that's very good for also for big data, for example. So the problem with DVC, and so if you want to keep track of everything and to keep tracking of pipelines, the problem with DVC is that as you keep adding extra and extra steps, you have to be extremely careful to tracking all of your dependencies. So you have to manually say that you want to run this script that depends on these files and will generate these files, and that's the way that it creates a pipeline and the graph of dependencies that is able to create this version control. So if you miss something in between, DVC will not detect it. So you have to be extremely careful. So as you were the same process that you were using, if you are using a Git repository, you have to also do with DVC. So it's extremely versatile, and it's extremely simple to use, even if you are using on a small project. And for experiment management, I think that it's extremely useful, even if you, let's say, you don't pick a project in 6 months and come back 6 months later. The benefits of this is that you can have access to the cache repository and just say, similar as you did with Git pull, on your Git repository, you could say DVC pull, and it will pull all the data pipelines and information to be able to get the setup of a project in a matter of minutes. So it's very useful to reproduce pipelines. But I think that it's extremely useful, and I will be talking a little bit more on the demonstration later. But the problem with DVC is that, despite of trying to integrate this with DVC metrics, is that it still doesn't do metric tracking. So if you're running multiple experiments, they have a suggestion for like having different experiments on different branches, but in my experiment it's not a very well suited, at least for my workflow. And so what I like to do is combine this pipeline management and this data version for our production models, so version our production models and our experiments of our production models, but also combine this with an experiment management platform that is able to centralize all the information of all the experiments that I did, because I don't want to store every model and every pipeline of every small experiments that failed. But I want to know what I did and what metrics did I had, and have a report of all the process that I did in a machine learning or data science project. And that's why I like to combine these both worlds. So let's talk about experiment management and metrics tracking of our experiments. I think that is extremely important to do this. I don't think that any one of us likes the using spreadsheets and custom logs to log results, but we all have been at that point. But today there's no longer the need for doing that. There are tools that do this for you in a secure and private way, and you will be able to create a centralized platform that just work as a server to log your experiments and to create to create an interface to log all of your experiments and work. So I will be talking a little bit about these experiments, these tools: Comet, Sacred, MLFlow, Neptune, and weighted biases. There are other ones. I cannot talk about all of them. I will talk a little bit about the ones that I experimented. So let's start with Sacred. This one is it's popular. It's open source. It's free. It has a strong community. It stores the experiments and the artifacts of your experiments on a database of your choice. The problem with this is that you have to host it somewhere. So it's not like it's in comparison with other tools in which we have a website which is accessible to everyone with a key or with a password. You have to host it somewhere and store it in a local or in a remote machine that stores all your experiments. So it needs some non-trivial code adjustments. But basically it's extremely popular, and the problem with this tool that I found is that it's not much of a collaboration tool. It's just like a central repository for your experiments and metrics. And only works for Python. So if you have projects with R or other tools, you can't use it. So basically, it has an interface that you can host, that you can add logs, you can add metrics, and you can see that this is extremely a lot better than having this on a spreadsheet or on a text file with all different metrics. So I think that it's very good if you want an alternative for having self-host in some projects. For example, if your company or where are you working doesn't want to have their experiment hosted in an external server, this might be a good choice for you. So you can see that you can log plots, you can log metrics, you can log whatever you want, artifacts, models. So and you can see that you have there are other ways of doing this, but you basically use decorators, and it allows you to create an experiment, log the metrics, log the parameters, the model artifacts, and it just goes for your local server, and then you can visualize it on the interface and compare the models. So another alternative is MLFlow. This one is also open source and it's free, and it offers a little bit more than the other ones, because It's very popular across the industry because it also has it's not only a machine learning experiment tracking tool, it also has a MLFlow projects and deployment, which provides tools for extremely useful tools for versioning of your projects, of your dependencies of the projects, and deployment of your models in a for example in a REST API, or for example for a remote AWS or Google Clouds or Azure server. So extremely focused on not only experiment tracking, but also on production, on how to deploy the models. It's extremely useful, and if you want something that is also hosted in-house, not in an external server, MLFlow is the one that I will highly recommend. It's extremely useful, it's extremely simple to use, and basically even if you want to even if you can use an external server to log all of your metrics and your reports, MLFlow can also be integrated in other tools, as I will be talking a little bit after. But I highly recommend this tool. It is extremely mature tool. You can see it has a good looking interface, so you can log all the metrics and everything that you want. So you can compare experiments, compare metrics, compare graphics. So you can log images, whatever you want. It's extremely good. And you can see that like it's you have like you just want to start. MLFlow is extremely easy to adapt your code to log the metrics and log a parameter of your machine learning model. So yeah, you can log models, you can log metrics, you can log parameters. So everything that you want, it will be there. And the cool thing about MLFlow is that if you log a model with their architecture, you're automatically ready for deployment later. Even if it is a scikit-learn model, if it is a Keras, TensorFlow, PyTorch, whatever it is ready for deployment, which is extremely cool. So weighted biases. So it's it has collaborative reports, fast tracking, scalable, hyperparameter tool, and model and pipeline and data versioning. I will say that this one I wanted to mention, but it's the only one that I haven't tested, but is extremely popular in the recent years. But you can see like you have the difference between this one and MLFlow is that MLFlow is a lot more mature, but weighted biases is extremely popular on research. And basically you have like a free and a paid version. Like for researchers, generally these tools are completely free, so it's really cool. And basically weighted biases, the difference between MLFlow is that weighted biases hosts the experiments in a server, which you have like a key or a password to remote but it's completely private. You can compare experiments, you can have the interface and compare hyperparameters. It's extremely cool interface, like as you can see. And it's also you can add the report of your experiments. So I think that if you have this opportunity, weighted bias is extremely useful. I haven't used it on a daily basis on a project, but it's very popular nowadays, so I wanted to mention it. So you can see that it's extremely, they are until now they are completely similar in a way in which you adapt your code and adapt your to log the metrics and the model. So basically you can see like you can have like if you use TensorBoard with TensorFlow, you can log automatically with weighted biases, and everything is automatically track it. So it's extremely cool. So Comet.ml is one of the popular tools, if not the most popular. I think it's extremely well designed. It has it's continuously integrating new features every month, and basically it allows you to create experiments, to compare experiments, to collaborate online across teams. It allows you also as a feature to debug your models. It has a REST API to manage your experiments, and basically I think it's the only one from what I saw that has a support to logging audio files. So basically it also has a neural architecture search feature that you can use to optimize your architecture to your problem. So it's extremely popular. It's extremely easy to adapt. It also has a way to reproduce your experiments, but it doesn't track the pipelines as you do on DVC, and that's why I say reproduce an experiment, kind of. It also has the availability to use Python, R, Java, and also a REST API. So, and the cool thing that you can also use with Comet is that you can use and integrate MLFlow experiments here. So if you want to use all the tool package of MLFlow to deployment and to project versioning, you can also integrate it with Comet and and host those experiments with Comet.ml. So it's extremely cool platform. I highly recommend it to test it. All these tools have the ones that are paid have free tiers, so you can experiment and use and see which one is best suited for your workflow. So I highly recommend Comet to give it a go. So you can see it's extremely cool interface. You can see that now that all of these ones are similar to each other, and they all keep adding features that make these tools similar to each other, like for example the hyperparameter comparison, the plots that you can add to compare metrics, the loss functions that are being plotted here. So it's extremely cool, and the organization that you can add to your project is extremely cool, and it's very collaborative in a way that you can have a team working on the same project and compare the experiments of the teams and comment and things like that. It's extremely cool, and each month they keep adding new features, so that's extremely cool. So you can see like it's extremely useful to, like, they have a cool thing that is extremely also I haven't seen this in other tools, is that they have like a way of encapsulating the train code and the test code and the validation code, in which they have like in which you can log different things, and it can be extremely useful for training different experiments. So I highly recommend this Comet.ml. So in a similar way, Neptune.ai, so basically it's very similar to Comet, is not as mature as Comet, but the biggest advantage which I see to Neptune.ai, and that's the one I personally have been using in the past year or so, is that Neptune is extremely well designed for team collaboration. So what do I mean by that? Is that basically you have the cool interface as you did on the previous tools. You have the similar the similar experiment management and comparison as the previous tools, but the cool thing here is that you can effectively share, comment, organize your reports inside of this tool. So basically, let's say you are working remotely, or you are working with a multiple team that is doing the same experiments for the same project, and you want to comment those experiments, you want to create a report and log to those experiments. Basically, Neptune allows you to create a centralized platform for not only storing your experiments, but also to be able to interact with your team, create your reports. Another person from your team will be able to comment the reports. You can tag other team members. You can do everything that I think that's what makes Neptune.ai so interesting, because it's extremely collaborative, and I think that if you want like a way that if you integrate it well with your workflow, let's say that you pass there not only your experiments but your reports, the logs, the history of your experiments, why did you did a lot of things. Neptune.ai is extremely useful. You can see here that you can tag experiments, you can comment, you can tag team members. It's very well suited for team collaboration, and it also has a thing that I extremely like, which is notebook hosting. You can log your Python notebooks, and basically also can have multiple versions of your notebook. So it's extremely cool also. So I will now do a small demonstration of this. Of these tools. I generally use DVC with Neptune.ai. So the cool thing about, I will go back firstly about DVC. Let's say that, okay, so I will start here. I started here. Let's say you have a Git repository, and you have a Git repository which you can basically create a Git repository remotely, let's say on GitHub, on Bitbucket, or whatever you want to use. And let's say you start from scratch. You probably will create a virtual environment with all your dependencies. Here I already prepared the code for, like, I have Neptune, I have DVC, Pandas, scikit-learn, matplotlib, NumPy. Yeah. I don't have the version because it was just a demonstration, but you get the point. So the first thing, like if you add on a GitHub or something like that, you don't have to do git init, but you could have a script that basically did the setup of the project for you. You basically create a virtual environment, install the requirements, and the first thing that you have to do is DVC init. This is what gives the information to the inside of your virtual environment, because DVC works in a way that is a pip or a conda dependency, a Python dependency, in which you just run DVC init and it creates all the dependencies. So basically what this script will do is initiate the DVC, and let's say that you have a data set, which in this case is a housing prediction data set. And let's say that so you can see here is a CSV file. Let's say you have, it's for your project, you want to predict the price of the houses from these features. It's a popular data set, so it's just for demonstration purposes. So basically, let's say that what this will do is that it will create DVC init. It's the first thing that you need to do with DVC. and then it will add to tracking this dataset. So basically what this will do is add the, say DVC, that this file is a dataset or a file that we want to keep track. So basically then it will create a remote, which in this case I will be just using a local project DVC cache file, the directory, but you can use like Google Cloud. I highly recommend to see the documentation of this package, because it's extremely well designed and is extremely simple to follow up the steps. And basically I will say just save the remote cache files here on this folder, or in this server in your case if you want to use a remote server, and basically it will say DVC push. So DVC push is similar to git push, in which you push the code to a remote repository, and here I will just push the cache files for this housing file. So let's start by doing that. So I am in this file. Let's say I want to do this, so I will say start by saying scripts. I will make sure that I can run these scripts, and let's say that I just do the setup. So basically it will initialize the Git repository in this case, but it will install all the dependencies on a virtual environment. It will ideally activate it, and it will initialize the Git repository and the DVC. So let's wait a little. Hopefully it won't take too long, because I already have the cache of all these files. Okay, it's running the setup files. It's taking a little bit longer, but you can see that it's already no, just a second, it's already created the Git file. The Git repository is already being tracked. So let's see, it's running still the installation of some of the Python packages. So so what you can see, so basically what you want, so let's give it a little bit some time to work out, but basically let's recap a little bit of what were we doing. We are saying that we're creating a virtual environment with all the requirements that we need to our project. This is just something that you probably will already be doing in your project. You are adding you are saying DVC in it, so you are saying this Git repository is being tracked by DVC, so just use it. And basically it adds the CSV file to being tracked. You can see that after running DVC, so basically you can see that this has been added to our Git. So what is being tracked by Git is this DVC file, which you can see that has a hash file that is being used here. So it's the only thing that is being tracked is this. So let's start by just adding all this code and all these files and see what has been added. So basically you have like a git ignore file, you have a config for which is currently empty for the DVC, we have a diffusion. This is like DVC files for its interface. Basically it also added this DVC file. So let's add everything to our Git repository. So let's say git setup DVC init project setup. So yeah, so I added everything. So what does this mean is that I have now a remote repository that is being tracked, and currently the only thing that is being tracked is the dataset. So what means is that if I remove this file somehow, and if for some reason let's say I'm starting a project and 6 months later I come back to this repository, so I don't have the files because it's not being tracked on the Git repository. But if I have access to the DVC cache repository, ideally I could say DVC pull. Well, I'm not inside of the virtual environment. So I will say project virtual environment. I will activate the virtual environment, bin activate. Yeah. So if I say DVC pool, I noticed that I removed the housing, but now it's here again because it went to the cache file and it will get the housing CSV. What does this mean is that every time that you are tracking, that you go across repositories, across branches, DVCs as a cache file associating to each branch, and basically you can go back 10 versions before and 10 versions after a specific branch and just push all the pipelines and all the information about all the data that you were keeping track those experiments. So it's extremely useful. So let's start by doing some initial pre-processing. Let's say that I will start by doing a pre-processing, a basic pre-processing, and just do a split on basically which I will be doing a split, a train test split, and basically some pre-processing steps. So I will say that I will be using the housing CSV, so I will be storing the train and the test division on a specific folder. So basically what this does, what I need to do is so I will be inside of the repository, and if you want to add a first pipeline package, you have to do DVC run. The N flag is for the name of the current step of the pipeline, and basically you need to say manually which are the dependencies of the project, and that's where you can fail to use these tools. Because you have to be extremely careful to keep track of everything here. So basically I'm saying that I'm depending on the original dataset, which he already knows that we have a DVC file associated with it, and we also depend on this Python file which does the code, and it will generate an output folder which is going to be located on data division, which is going to be tracked as a cache file for our project. So basically it will, and then the final part of the project that it will run the script. So, and then it will push to the remote repository. You have to be you need to, as you keep committing to your Git repository, you need to keep pushing also to the DVC repository in order to keep syncing the Git and DVC together. So let's run this and let's see what it does. So if I do scripts and I will say divide dataset, which will pre-process the dataset, so running the stage. So what we see is that it added here some DVC files with some of the initial pipeline that is being added. So cool, we have a pipeline information here. So if you see here, it just adds this to your Git repository. So let's say I have it DVC added dataset pre-processing and train test split. Let's say this. Okay. So what does this mean is that, again, if I for some reason remove something, or just for mistake I remove something here, and for mistake I also remove the dataset division. So yeah, I remove it for some reason. This if I just do DVC pool, you can see that now again I have it here. That version of the dataset is here, and it's extremely useful. So after some while, let's say you come back some years, some months after, you can just do DVC repro, and it will say, in this case it says that nothing changed, but basically what's cool here is that for some reason the housing data set, let's say I will change year value from 35, let's say something changed. Ideally it will detect that something has changed, and it detected. And because of the original data set was different, basically it ran again the pipeline. So it's extremely intelligent. I didn't say it changed it. It detected it, compared the cache extremely fastly with the changes data, and basically what it says is that if you want to keep track of this change, just add it to the dataset. So let's say I detected an error on the dataset and I want to keep track. So yeah, bug correction, let's say, on data sample. Yeah, let's see this. Yeah, okay. So let's say you want to train a model. And that's here where you can integrate the pipeline, the DVC, with the Neptune experiment management. So if you want to train a model, I say here, like I'm training just for demonstration purposes, the number of iterations. I'm training 5 models with 3 cross-validation folds. I define the seed, the validation ratio. I define the parameters of the hyperparameter tuning can choose. Basically, I am loading the train file. I'm creating a Neptune init file. So this is what says to the code in the code that I'm going to be using in it. I will be creating, let's say, an experiment, which I will be talking about. Let's say quick start example. It will log the parameters of the experiment. So basically here, and basically it will have a stratified shuffle split, so it will be a stratified cross-validation. It will train a gradient boosting regression, and basically it will optimize with this metric. So basically, and then it will train all the models, and we will log the best model on Neptune, and we also be logging then on DVC. So we want to store the best model as a DVC file, because maybe you want to use it as a production model. So yeah, this is basically you can see it's extremely easy to just adapt your model, because basically you can log the artifact and on Neptune. So I'm also not only logging the model on Neptune, but also on DVC. Maybe you don't want to do that. Maybe you don't want to, for all the small experiments, log the model on your cache, on your Git repository. Maybe what I generally do is just log on DVC when it's a production model, and the rest of the models will go to Neptune. And you will see what I mean by that is that maybe you want to recover an older experiment, or you want to do an ensemble of models with multiple models that you train on a same data set. So I will use that Neptune for that. So in this case I'm going to use, so basically it will do randomized search cross-validation, and basically I have a script here which trains the model. What does this mean is that it's going to be the second step of the pipeline. So basically we have the train model pipeline step. It depends on the original CSV, it depends on the dataset division, it depends on this script also. If this change, something will change, and it also depends on the train, and it depends also on the train the Python file. So yeah, so it's also missing here one dependency that I actually noticed, is that it depends also on the dataset division. Yeah, I was missing this for some reason. So yeah, so basically another pipeline. So DVC run, the name of the pipeline. The D flag is the dependency, which is that this pipeline depends. So if something changed before, it will keep track of it. So it depends on the housing that they set, division, the Python file of the previous folders, and it depends on the scripts and the train file that is going to be running. So yeah, and it will generate the model file, which will be our production model. So yeah, and then in the end, again, it pushes to the remote track server. So let's run and say scripts 3. So it's going to be training a model. It's running Python source train, and so you can see that Neptune, it will say that it's been tracked to here. So it already trained the model, because I just trained a very bad model just for demonstration purpose and to be easy and fast. But basically you can see that it's storing this, and you can see that it generated the model file, which is the pickle file, which is not being stored by Git, but yes, by our DVC log. And you can see here is that we have small changes here. So yeah. So basically I will add this train model, and yeah, I will add this to DVC train production model. Yeah, so yeah, everything is here, and I will say that let's go to this project. So you can see that now Neptune, I already, let me just say that I already prepare all the logging, the experiment, because you need to have a private key that allows Neptune to validate that you are a correct user and you have the password. So, but I'm just wanting to show you that this can be done very easily. I don't have chart because I didn't log anything here, but you can see that it log all the metrics. We have the artifacts of the model, the model weights. We have the source code if you want to. If you don't want, you don't need to put here the code. I just like it because sometimes I'm not using small experiments, and I'm not tracking everything using Git. If I'm just changing a small little detail on hyperparameter tuning. And basically you can see here the parameters that I logged to the experiment, the details. Yeah, and I have here multiple experiments here. So you can see, like, you can go here and you can just yeah, I can just manage the columns. Let's say I want to some logs, like let's say some metrics that I want to see. Maybe I want to group by something, so it's extremely useful here. But the cool thing here is also that it allows you to have like a notebook. So let's say I have here something different, like you can have here a Neptune for something that you want. This is a public kernel demonstration that they have, but like you can put here reports, you can see here, you can put here, and it also has like a versioning, like you have checkpoints here, like of different things that you track with the same notebook, which is extremely useful. And another thing that I extremely like to use is that if I go here and just say, let's say I want to go to the project example, so let's say I have it here, so I don't have any notebooks, but what I like to do is here use the wiki. So basically here you can keep track of everything on your project. This is just a dummy project template just to show it, but basically log my tags, log my metrics, what I'm doing, basically I just have like different pages for different experiments. I can tag experiments. It's extremely useful for this, and basically what you can do here is like you can like do whatever you want here, like tag an experiment, mention a person, add a code block here. So it's extremely well suited for having a centralized platform for your experiments and your reports. So I highly recommend using it. And you can see like here, for example, someone mentioned me on the project architecture, and there was like also a dummy was also used as a tag in project description. So yeah, I think that this is extremely cool, like, and it's extremely useful to use this it's extremely powerful tools, and I like to use them both. What I also like to do is one thing that I also like to do is, for example, you want to see what is your currently DVC pipeline tracking. What you can do, like, DVC is extremely is a tool with extremely good documentation. So let's say you want to go to the Python API reference, the command reference. Let's say that you want to see you basically want to see the pipeline that you want. So you have here all these use cases. So basically you have here some very well documented examples. So basically, if I just do, this is what I was looking for. So if I do DVC tag, it will give you the pipelines that you have, and you can see that this is extremely cool because DVC is correctly doing, like, the train model depends on the dataset division pipeline step, and it also depends on the housing CSV dataset. So what does this mean is that, so I will end. So basically, what does that mean is that if I go here and for some reason my housing dataset again changes, let's say I will end it. Oh, I detected the bug on the dataset. So if I do this, and if I just say, okay, let me see something has changed, sorry, DVC repro, it will detect probably the change. It detected, it will run dataset division, and then it will run again the train dataset, and it will run another experiment on Neptune. So it's extremely useful. So maybe you have different dataset versions on different branches, and it will be a complete mess, and we all been on that situation. DVC is there for you because you can go back to that version. And it's just a matter of adding a little bit step of complexity of not only Git committing and Git pushing and Git pulling, and do the same for DVC. So that's basically what I wanted to show you. Basically, if you go here now, it detected it, changed it, and basically it updated the cache file. So I highly recommend you to use it, especially on production. And maybe Neptune, Comet, or other tool is it's better for your workflow. But I highly recommend you to test all these experiments, and maybe see which one is the best alternative for you. So thank you, and if you have any questions, if you have any suggestions, something like that, please send us a message. You can see here the email. So thank you for your time and for your interest on this talk, and thank you.